distribute. So this is 1 minus 2x squared minus x minus 6, which is negative 2x squared minus x minus 5. Do we understand how we get this? Okay. Which part? So is it clear why we replace g of x?
Okay. Yes, now it is.
Okay. Good. Now I'm asked to find f comp g of 3. Can anyone tell us what to do, how to do this? Right. So I have negative 2 times 3 squared minus 3 minus 5. Which operation I perform first? Not negative, but I have to square, which is 9. And 9 times negative 2, negative 18. And this is minus 8. So the answer is negative 26. I'm back with g comp f of x. I must write the definition first so I don't make an error. Can anyone dictate the definition first? Yes? Yes? Of? Very good. I start by replacing the inner function first. G. Can anyone tell us what to replace it by? Say it again. Perfect. Now take a moment, deep breath. Let's look at G. G says G of blah, whatever that is 2 times blah squared plus blah plus 6. So now I would like you to dictate. 2 times blah squared plus blah plus 6. Very good. Yes. Yes. You can put parentheses or not, but there is no need. Plus 6. 2 times blah squared plus blah plus 6. And I think possibly, hopefully, Tim would like to give us the contract on 1 minus x squared. I'm hoping, but I can't force him. He declined. So what do I write? I can't. I cannot. We have a contract.
No, it's 1 plus 2 minus 3. That's minus x squared.
Thank you very much, Tim. I'm going to add these two. So minus x plus 7. Only now I'm allowed to distribute. Well done. So 2 minus 4x plus 2x squared minus x and plus 7. I rearrange everything in descending order. 2x squared minus 5x plus 9. So now I'm asked to find g comp f of 3. I have the function. I have g comp f. What will I do next? Help. Very good. Which operation I perform first? Yes. So 9 times 2. Minus and plus 9. 18 minus 15 is 3. 3 plus 9 is? Very good question. Really very good. Any questions for me? Any questions?
So So you always do the inside first.
Absolutely.
Okay.
Let me say one more time why. G is applied to x. I get g of x. And then I apply the outer function to g of x. Better? Good. Now, here's a question for you. I'm going to give you a function. I'm copying it from page 311. I'm going to copy 76. So this is function h of x, 2x minus 5, everything cubed. I want an outer function and an inner function. So I want the inner to be g of x, and I want the outer to be f of x. So here's the idea. We are looking at a function, and we are asked to decompose it. What am I doing now? I'm going backwards. This is a function composition. It was created from at least two functions. One which is the inner, and one that is applied to the inner. Can you guess, by simply looking at the function, which one is the inner and which one is the outer?
2x minus 5 is
Must be the inner, right? This is what I have to do first. So the inner is 2x minus 5. Now, keep in mind, I'm getting one number. One number. 2x minus 5 will be one number. What function I apply to that number? Very good. That's it. If you create the function composition in this order, f, g, you will get that function. So let's look at one more. Let's say 82. So this is function decomposition. There is not only one correct answer for this. I may find two other functions that will give us 2x minus 5 cubed. Okay? So 82, we have h of x, which is 1 over 4x plus 5. I want an inner g of x and an outer f of x. Please decompose this function into two functions. One which is the inner, one which is the outer. Say it again.
Is one the outer?
I cannot start with the outer.
4x plus 5.
Indeed. So the inner function is 4x plus 5. I got a number now. I got one simple number. Which function I apply to this one simple number?
over x.
Done. That's the function decomposition.
So will you tell us which one is the outer?
By the order of operations.
No, I'm saying like could g of x be?
Oh, if you are given f come g, g must be the inner. Or you can say, I'm denoting this by the inner and this by the outer, and I'm fine.
Oh.
You decide. As long as they are in the correct order, the name is not important. Yes, please, Marcus.
How would these questions be worded?
Find the inner and the outer to decompose the function f of x, h of x. Express the given function h as a composition of two functions, f and g. It doesn't say which one is the inner, which one is the outer, but it says h of x equals f come g. So it's clear that g is the inner.
Oh, okay, so it'll say it in the.
It will say it in the problem, yes.
Okay.
Good. I would like to look at one more problem. And this is 92 on page 311. We're asked to find f come g of 1. We don't have f, we don't have g. We are given graphs. But can anyone tell us what to do here before I look at the graphs? What will you write? F of G of 1. What will you have to determine first? I have to find G of 1 first. So let's look in the book. Okay, here's what we have. The blue graph is F. The purple graph is G. We want to find G of 1. G of 1 is -5. So let's write it, -5. So -5, which means F of -5. I go back to the graph. Say it again.
You can't see it.
-5.
Are you?
On the
G of
right side.
is -5.
It's cut off.
It's -5 right here. Okay, so now let's determine F of -5. So here's -5. How much is F of -5? F of -5 is 3. Very good. That's how we determine values from graphs.
Just looked at one and picked it up from multiple. The X value in one.
No. F come G of 1
I'm looking at the graph.
to 1. I apply G and I get -5. To -5, I apply F and get 3.
If you read the graph, you just go with 1.
Say it again.
I said if you look at the graph, and just
Yes.
go to the X value of 1, you can say
But this is F of 1. You understand what I'm saying? You have to go through the steps. It happened that at 1, we got F to be 1. But we're not asked to find F. We're asked to find F come G of 1. Is that better? Is that better? It happened that in this case, it happened to be the same. Okay. Any questions? Any questions? Okay. 2.7, entitled, I really don't want to put the title right now before I explain something. If you remember when we started functions, we created 3 scenarios. In the first scenario, some time ago when we started chapter 2, we had something like this. And then we had something like this. Whatever number you want to put in here, doesn't matter. And then we had something like this. Any numbers you want. And we analyzed these 3 situations, and we said the first situation is or is not a function. Is. Every every input corresponds to only one output function. What did we say about the second one? Relation. What did we say about the third one? Very good. To each x, only one y. It happens that 2 x values go to the same y. That has nothing to do with it being a function or not. Also, when we started, I said there is something special here going on that this one has, but this one doesn't. And I was saying, going backwards, is this a function? It's called 1-to-1 then. 1-to-1, meaning even to each one, even to each y corresponds back only 1x. To each y back 1x. To each y back 1x. This is 1-to-1. Because going backwards, I can or I cannot create a function. I can. Very good. What about the last one? Is this function 1-to-1? In other words, I'm saying Going backwards to each y, do I have only one x? No. Exactly. So this is not one-to-one. You either write it like this or you write it like this. So then I'm going to say only one-to-one functions have, you already said it, inverse. They're called, very good, they're called inverse functions. This one has an inverse, but it's a relation. This one, there is no discussion here, it's not even a function. But this one has a function. Yes, this one has, it exists, but it's not a function. So only one-to-one functions have inverse functions. That have inverses, there are functions as well. Okay. We will learn how to find the inverse of a function. But before we do that, I want to analyze one more situation with you. Let's say f of x is 3x. What does this function do to x? Excellent. Did you hear? It multiplies all x values by 3. I would like to create a function that does the reverse operation. Not the opposite, because that's not the case here, but the reverse. It undoes what this one does to x. That's it. Now here's a question. Do you think that these functions are inverses of each other? Here's what I mean. One simple example. I give you $5. And then 3 minutes later I come back and say, give me my $5 back. What's the deal? What happened? You still have exactly what you had before. I gave you 5. Nothing happened to x. You have in your pocket x, whatever x is. And I'm giving you 5, so now you have x plus 5. But then 3 minutes later, I change my mind. I say, give me my 5 back. Are these operations inverses of each other? Giving you 5 and then taking it back. So that's why you still have your x and nothing else. Nothing happened to it, correct? What do you think these two functions, are they inverses of each other? Like my explanation, I'm giving you 5, but I'm taking it back. Let's discuss that. You say yes, some other says no. Okay, very, very good. What do you think the function composition both ways is? We will determine it in a minute. Well, what do you think f comma g will be if they are inverses of each other? Say it again.
Same answer.
Which is?
X.
Say it again.
X.
Indeed. Thank you. Nothing happened to x if they are inverses of each other. It's like my silly example. I'm giving you 5, but I'm taking it back. So this is what it's called, the property of inverse functions. So now I can put in my title, inverse functions, of course. That's the title of 2.7, inverse functions. So I'm going to write this one more time. And I'm going to write what it is. So f comma g of x equals x, and g comma f of x equals x. This is called the property of, what do you think? Inverse what? That's it. So I haven't convinced you yet. I had a yes and I had a no. So obviously I have not convinced you that these two are inverses of each other. What do I have to determine? I have to determine. Look at the definition. And you will tell me what to determine. Exactly. And right, what should I get if they are inverses of each other? Right, What if I get 5x plus 9? They're not inverses of each other. They're not canceling their effect on x. One does not annul the other. Right? So let's find f comma g. What is the definition? What do I have to write? Yes? F of? Awesome. F of g of x. F of? Very good. That's what g equals to. And now I'm looking at f. What does f say? 3 times blah. It doesn't say 3x. It says 3 times whatever.
X over 3.
3 times x over 3. What is the answer?
X.
So if one side is x, the other one will be x, but I have to show it. I can already conclude what? That 3x and x over 3 are inverses of each other. So let's find g comp f. So this is clearly x, but I have to check this one. G comp f of x. I have to write the definition first. Very good. Where do I start? Yes? Very good. Now I look at g. What does g say? It does not say x over 3. It says blah over 3. Very good. What is the answer? What do we conclude about f and g? Since f comma g as well as g comma f, they give us plain x. It means, look, I'm applying two functions in two different orders, and I still get plain x. What is happening here? One is annulling the effect of the other on x in both directions. So what do I write? F and g must be inverses of each other. Very good. Any questions so far? So number one, I'm hoping that you are going to quickly do all these problems and check the answer in the back between now and Wednesday. And now I would like us to pick some problems from here so you have everything you need. Page 321, 322, 1 through 43. So let's start with 1 through 10, first of all. We already did an example, but let's choose a problem from 1 through 10. We want to look at 2. Perfect. It's the same thing, right? It's 6x and x over 6. Let's pick another, because we had 3x and x over 3. So let's pick 5. Oh, I'm sorry, 6. So we have f of x, 3x minus 7, and g of x, which is x plus 3 over 7. They're asking us, use the property of inverse functions to determine whether they are inverses of each other. What do I have to determine? F comma g of x. Very good. By definition, f of g of x. Good. Where do I start?
G.
Yes, perfect. So f of?
3 plus x plus 3 over 7.
Perfect. Awesome. Next, I'm looking at f. What does f say to you? And don't say x. F says 3 times blah. I'm trying to be funny. As long as you remember, I'm fine. 3 times whatever, and then it's not done. 3 times whatever? Minus 7. So please dictate. 3 times whatever.
X plus 3 or 7.
And then, very good. So 3 over 1, I have to distribute. So it's 3x plus 9 over 7 minus 6.
Yeah, it's minus
But it's minus 7.
Oh, I'm sorry. I'm not sure why. No reason. I don't know why I said 6. My apologies. Then, the least common denominator, please. Good. What do you multiply the top of the second fraction by? 7. So dictate, please. 3x plus 9 minus. So this is 3x minus 40 over 7. Does this equal x? Does it equal x? No. So what do we conclude? Not inverses. I don't have to determine the other one. I don't care what happens to the other one. If one of them is not x, not inverses of each other. Okay, here's an example. I'm picking 16. F of x equals 3x minus 1. What is the graph of this function? First of all, what function is it? A line. It's a straight line. Is it like this with a positive slope, or is it like this with a negative slope? It's a positive slope, right? Positive slope 3. Okay. Is this a one-to-one function? Not. Is it a function, first of all, by the vertical line test? But is it a one-to-one? To each y, only one x. By the horizontal line test, this is one-to-one. Good. So we know that the linear function is one-to-one. So here's the graph. I'm not determining anything. I'm just saying this is the graph of a linear function. By the horizontal line test, this is one-to-one. If it is one-to-one, then it has, awesome. Because it's one-to-one, it has an inverse. We're asked to find the inverse. Find the inverse of f of x equals 3x minus 1. There is a 4-step procedure. Have we had any 4-step procedures in the past in this course? When?
10 minutes ago.
Oh.
Complete the square. You did? I'm sorry. I'm sorry. I didn't hear it. I'm sorry. My apologies. My apologies. I'm sorry. I'm sorry. Indeed. Good. First of all, the notation. I need to talk about the notation before we go. The notation for F inverse. For F inverse. This is the way we read it. F inverse. The notation is this. And no, it does not mean 1 over F. This is the notation, F inverse. That's how we read it. It's the inverse function of function F. F inverse. Okay. Step number 1. And you tell me if this is legitimate. Replace the notation f of x by y. Am I allowed to do that? Right. So in other words, I want to write this as y equals 3x minus 1. Am I allowed to? Am I allowed to replace this notation f of x by the notation y? because they mean the same thing. They are determined in the same way. They are graphed in this on the same place. Good. Perfect. Step number 2. Interchange x and y, or replace x with y, or y with x. And you should say, wait a minute, that part is not clear. And I will answer to that in the following way. The function takes x to y. Would you agree? So this is x and this is y for function f. Agreed? But now function f inverse will go this way. This will be f inverse. What does this value represent for f inverse now? Exactly. That's the reason why I replace y by x. Because y is y for f, but this value is x for f inverse. So that's why I'm allowed to interchange x and y. So where I see y, I put x. Where I see x, I put y. What am I solving for now? Exactly. Y is f inverse. So number 3, solve for y. How do I solve this equation for y? No. I'm solving for y. Y is the variable. Yes. X plus 1 equals 3y. And finally, yes. And you can write it, this time you can write it like this. Can anyone give us f inverse? In the final step, I replace y with the notation f inverse. X minus 1 over 3. X plus 1 over 3. I'm going to ask you this question now. F inverse. So the composite of this function and this function. And the other way. What should this equal to?
X.
Y.
No, not y, x.
Right, but why? It's correct. Why? Because that's how I determine this. It must be the case, otherwise this is a mistake. This is determined as the inverse function of this. Obviously, the function composition in any direction must give us x. There is no other way, because I already know they are inverses of each other. Any questions? Any questions?
So what is that property called? Is it a property?
Yes, it's the same one. Yes, we will in just 1 second. It's the same thing,
Oh.
but I replaced g by f inverse and g by f inverse. Yes, please. Shall we go ahead? So we want to find the f inverse? That is mean. That is mean. I will not put a problem like this on a test. Okay, we are told that this function is 1-to-1. It's too long. That's the only reason. And I have situations like this that I test you with in other things. Good. We are told this is 1-to-1. Step 1. Yes. Perfect. Step 2. Very good. Step 3. Good. What do I do? I'm giving you one little hint, which I'm hoping that by now you are very proficient with. What am I really saying to you when I put 1 under x? So y plus 14 equals I have to multiply x by y and x by -7.
X, Y, and 7X.
Good. What am I solving for?
Y.
Good. How do I do it? What will be the next step here?
Round by 2.
Can't. I'm solving for y. I have y on both sides. I'm not there yet.
Factor.
I'm not there yet.
14.
14 is not the issue.
Add Y.
The y is not the issue. I have y here. Why would I move it there?
You gotta get that to the
Add
outside.
Y.
I can't do that yet. I'm solving for y, but I have y on two sides. I can't.
Plus one side.
Yes. So y,
Minus X,
awesome, equals. Yes. Yes. That I agree with. Perfect. Thank you. What now?
Y plus X.
I cannot do that. There are two key words. Two key words. Is it in? Yes. Awesome. Yes. What? How?
Take
Exactly.
and 7 out.
I don't need that at all.
Okay.
It's not a mistake, but there is no need.
X minus 1.
Y.
1 minus x.
Thank you. And I solve for y.
5 by 1 minus X.
And this is the F inverse. I have 2 more minutes that I would like to come back to the previous example. And where is my previous example? Here it is. We had in the previous example f of x equals 3x minus 1, and we had f inverse. We determined it as being x plus 1 over 3. I would like to graph this function. What type of function is it again? Excellent. When x is 0, y equals -1. What is the ordered pair? Perfect. And then I want when y is 0. 1 equals 3x. 1 equals 3x. 1 equals 3x. X equals 1/3, and the ordered pair is?
1/3 0.
Good. That's all we need to graph f. Agreed? Okay, so let's graph it. You said 0, -1. And you said 1/3, 0. This is the function f of x. Agreed? I want you to give me 2 ordered pairs so I can graph the inverse function. How do we know that? Awesome, thank you. -1, 0 would be a point for the y, for the inverse function. And another one? Thank you so much. Exactly. Why? Because the function brings 0 to 5, and the inverse function takes 5 back to 0. As an example. Very good. So -1, 0, and 0, 1/3. And this is always the case. I know, okay, I'll stop right this second. This is always the case. Look here. Can anyone give us the equation of this line? It's on our list of functions, the very first one.
So yes.
That's it. So I'm not going to hold you now, but I was going to write, but there is no more time. I don't want to, as I said, it's disrespectful to hold you over. So I apologize for my disrespecting you.